Today we're going to talk about angles and degree measure. First, what is an angle? An angle is two rays that share the same endpoint. Remember that endpoint is known as your vertex. So over to the right, we have an angle. Notice the arrow is telling us what direction that we're moving in. Alpha is simply the name of the angle. So notice it's starting at that bottom side. Your starting point is known as your initial side. So where your angle starts is your initial. Where your angle stops is called your terminal side. Now we have two types of angles. We have a positive angle and a negative angle. Well, if we are working counterclockwise, it is going to be a positive angle. It's going to be a positive angle. If we're working clockwise, it's going to be a negative angle. So let's take a look at what a positive angle would look like. Let's say my initial side is right here on the positive side of my x-axis. My vertex is at the origin, and let's say my terminal side is in the second quadrant. So if I start at my initial, I'm going to work counterclockwise. That would represent a positive angle. Now, if I do the same thing, so my vertex is at the origin, my initial side is on the positive x-axis. This time, let's say my terminal side is in the third quadrant. So this time, instead of going counterclockwise, I'm going to go clockwise. So that means I would be going down, hence it'd be calling a negative angle. So the direction in which you work is going to determine whether it's representing a positive or a negative angle. Now, you'll see a lot that it says it's an angle's in standard position. What does that mean if your angle's in standard position? Well, the first thing that it means is that your vertex is at the origin. So that's the first thing that has to be true in order for your angle to be in standard position. My vertex is at the origin. The second thing that has to be true is that your initial side is the positive part of your x-axis. All right, so I'll give you an example right below. So let's say, okay, I'm going to have my vertex at the origin. The initial side is the positive side, so it's the right side of your x-axis. Now, let's give an example of an angle that is a positive 120 degrees. So if it's 120 degrees, it's past 90. So it's going to be here in the second quadrant. So this right here, I'm going to work counterclockwise. So this angle right here would be 120 degrees. Now, just so you have a visual, let's see, use the same value, but let's say we had an angle that was negative 120. So it's in standard position. So my vertex is at the origin. My initial side is the positive x-axis. Now, instead of working counterclockwise, since it's negative, I'm going to go down. So if I go down, I'm going to go past 90. So notice there's a difference. This right here is what a negative 120 angle would be. So notice my positive 120 angle is in the second quadrant. A negative 120 degree angle is going to actually be in the third quadrant. So it does matter whether an angle is positive or negative, it's going to affect where your terminal side will be. So pay close attention to that. The main part of today, what we're going to talk about, are degrees. Realize the degree is the most common unit for angles that is going to be used. And that's what you saw in geometry. Now, an angle can be described in what we call degree, minutes, and seconds. So an example would be, they may say, okay, an angle is 15 degrees, 49 minutes, and then 21 seconds. So notice the degree is being subdivided into minutes and seconds. And it's just like a clock. So 1 degree is going to equal 60 minutes. 1 minute is going to equal 60 seconds. So now we're going to learn, how do we convert between decimals and what we're going to call DMS form, which is degree, minutes, and seconds. So let's take a look at example number 1. It's starting out as a decimal, and I want to change it to DMS form. So the first thing you're going to start with is your whole number. Your whole number is going to be the degrees. So there's going to be 15 degrees. Then you're going to take this decimal part right here, the 0.735. I'm going to take that, and I'm going to multiply it by 60. So if I take that real quick and multiply it by 60, you're going to get 44.1. So I still have a decimal, so this right here is my second, that's going to be my minutes. Now I have to take that 0.1, and again, because there's 60 seconds in a minute, I'm again going to multiply by 60. So I take 0.1 times 60, and that's going to give me 6 seconds. So if I combine all that, I'm going to have 15 degrees, 44 minutes, 6 seconds. All right, so let's take another look at another example. So again, my whole number, that's easy, that's going to be my degrees. Now I'm going to take my decimal part. Because there's 60 minutes in a degree, I'm going to take that and multiply that 0.125 times 60. So 0.125 times 60 is going to give me 7.5. So this part, that 7, is going to be my minutes. Now I'm going to take that 0.5, and again, because there's 60 seconds in a minute, I'm going to multiply it by 60. So 0.5 times 60 is going to be 30. So that ends up with my seconds. So if I combine it in one line, it's going to be 329 degrees, 7 minutes, and 30 seconds. So that's how we convert decimals to DMS form. Now, the last thing we're going to do is talk about how do we convert DMS to decimal. So we're going the opposite direction. Well, the 39 is a whole number. So I'm just going to take this and carry that 39 down. Plus, now I have to convert this 5 minutes into a decimal. So because for every degree, there's 60 minutes. So we're going to multiply by 1 over 60. So that way, see how my minutes cancel. Then I'm going to plus, I'm going to take 34. I want degrees, so degrees goes on top. How many seconds are there in a degree? Well, there's going to be 3,600 seconds in a degree. So we're going to multiply by 1 over 3,600. At this point, all we have to do is enter this in our calculator. So we're going to say 39 plus 5 times 1 over 60 plus 34 times 1 over 3,600. And if we get a decimal, you'll notice it goes 39.09277 and then keeps going on. We just want to go 3 decimal places, so we're going to go ahead and round to 39.093 degrees. And that would be your final answer. So let's look at one more example. All right, so we're going to start with our whole number, which is 35. So we're going to say 35 plus. Then we're going to take the minutes, which is 12. For every degree, there's 60 minutes. So we want our minutes to cancel, so that's why you're putting 60 at the bottom. Plus, I'm going to take my seconds. For every degree, there's 3,600 seconds. So I'm going to put the 3,600 on the bottom. So that way my seconds cancel. Now everything is in degrees, so I can simply type that in my calculator and add those together. So I'm going to take 35 plus 12 times 1 over 60 plus 7 times 1 over 3,600. If you take those, add them all together, you're going to get 35.201944, and it keeps going. Remember, we only want 3 decimal places, so we're going to get 35.202 degrees, and that'll be our final answer. Now, this may be a little confusing, but if you have any questions, make a note of it on these notes, and we will discuss them in class the next time I see you.